This is Service Mesh 101 with Linkerd. My name's Alex Leong. I'm a software engineer at Buoyant. I'm one of the maintainers of the Linkerd project, and I'm here to tell you a little bit about Service Mesh and Linkerd. So Linkerd is an open source service mesh, and it's a member of the CNCF. I'm going to talk a little bit more about what a service mesh is in a moment, but just in a nutshell, Linkerd is really committed to open governance. It's built to be incredibly lightweight, security first, and it's written in Go and Rust. So today I'm going to give a little bit of an overview about what a service mesh is, and then we're going to dive right into how to install Linkerd and to get some value from it using the dashboard and the CLI. Now in Kubernetes, you'll typically have a number of different pods which are all communicating with each other to accomplish some purpose. And they may be communicating over HTTP or some other protocol. So you can see in this example, we've got 3 pods, A, B, and C, and they're all talking to each other. Now, when you install a service mesh, what you're doing is you're adding a proxy container to each one of those pods. So A here gets a proxy, B gets a proxy, and C gets a proxy. And those are called sidecars. And what those do is they'll intercept all of the traffic going in and out of those pods and manage it. So now, instead of A and B talking to each other directly, they now talk through their sidecar proxy containers. And all these proxies taken together make up what we call the data plane. Now, different service meshes have different proxy implementations that they use for this. For example, Istio and Kuma use Envoy as their proxy. Linkerd, on the other hand, has a purpose-built proxy. It's just called the Linkerd proxy. And that's what makes Linkerd so fast and so lightweight compared to the alternatives. Now, in addition to having this set of proxies that manages all the traffic going in and out of these pods, there's another component called the control plane. And the control plane sits outside of all of that and manages those proxies. It manages their configuration, it manages their cryptographic identity, so it pushes down certs to them, and it also collects telemetry data from them, things like metrics and traces. And these two parts taken together make up the service mesh, the data plane, which is made up of these proxies, and the control plane, which manages those proxies. So hopefully that gives you a pretty good idea at a high level of what the service mesh is, but it doesn't really tell you why you would want that or what value that it gives. And so having these proxies everywhere gives a lot of benefits that mostly fall into 3 distinct categories: observability, security, and reliability. On the observability side, since you have these proxies which are intercepting all of the traffic going in and out of your pods, they can collect a lot of really interesting traffic metrics about those requests. So you can calculate things like request rate, success rate, and latency. And you can aggregate this data across many different dimensions. So you can look at, what is the success rate for traffic from pod A to pod B? Or what is the latency for 503s sent to pod C? And you can ask a lot of really interesting questions of this data. And this is all sent to Prometheus, so it's collected in a time series way, so you can see these trends over time. Because these proxies are also seeing all the traffic that's flowing through them, you can do request inspection as well, which means you can ask a proxy to tell you about the requests it's seeing, which is a really useful debugging tool. On the security side, the control plane gives a cryptographic identity to each one of the proxies, which means that you get mutual TLS between all of your pods on by default and totally transparent to the application. So the application doesn't need to opt into it, doesn't need to manage certificates. It's all handled by the proxies. And finally, there's a whole bunch of reliability features you get by having these proxies there. Because these proxies are aware of request latency, they can do latency-aware load balancing. They can notice that certain replicas may be faster or slower than others, and they can shift traffic so that more of the traffic is going to the faster replicas and back away from the slower ones. Linkerd can also be configured to retry if it notices that requests have failed, or to add timeouts if requests are taking too long. Okay, so let's see it in action. If you'd like to follow along, all the instructions for everything I'm about to do are at linkerd.io/getting started. So the first thing we need to do is install the Linkerd CLI. And we can do that by curling an install script, run.linkerd.io/install, and piping that to sh. If you don't want to do that, you can also download the binary from the releases page. So we can see that Linkerd 2.9 was just installed. There's some instructions here for adding it to your path, but I've already done that. And if we run Linkerd version, we can see that we have a client version of 2.9. That's the CLI we just installed, but there's no server version because we haven't installed this on our cluster yet. Now, before we install this on our cluster, we want to make sure that there's not going to be any problems down the road. So what we can do is we can run linkerd check -- pre, and this will do a pre-flight check and make sure that our cluster has everything that it needs in order to install Linkerd on it. So it'll check, for example, the minimum Kubernetes version, and that we have all of the applicable permissions that we need in order to install. So this looks good. We're ready to go. We can run linkerd install. And what this command does, I'll just run it now, you'll see that it spits out a whole bunch of YAML manifests for the Linkerd control plane. And so in order to install Linkerd, all we have to do is pipe those manifests into kube control apply. And so you can see now all of those resources being created in our cluster. And right away, even while those resources are being created and coming up, we can immediately run Linkerd check. And this time we're not using the -- pre flag, we're just doing a regular check. We're just going to go through a checklist and make sure that Linkerd is installed correctly, that all of its components are up and healthy, and that there's no problems with the installation. And so you can see here that this one container is not ready yet. It's still being created, and it's going to wait here for that container to be created and to become ready. And it'll let us know once the installation is complete. Great, so we see that everything's been installed correctly, and there's no problems, so Linkerd is now installed and we're ready to go. So the first thing I want to do is run the Linkerd dashboard command. And what this will do is it'll open up the Linkerd dashboard in a local browser window. And you can see already there's a whole bunch of really interesting data here. This is a list of all the namespaces in our cluster, and you can see the Linkerd namespace here, which is where the control plane is running. And you can see already we've got some interesting metrics here. We've got success rate, we've got requests per second, and we've got some latency data about the Linkerd control plane itself. And we're going to explore this dashboard a lot more in a moment, but I just wanted to take a quick look at it. So next we're going to install a demo app to see how this works. So we have one called Emoji Photo. You can download it from run.linkerd.io/emoji-photo.yaml. And so we're just going to curl that and pipe it to kube control apply. So we've created this new demo app. It's in the Emoji Photo namespace. And we can see what that demo app looks like by port forwarding. So we can do kube control port -n emoji photo, port forward service web service, and we can port forward port 80 to port 8080. And then we can look at that in our browser. So this is a simple emoji voting application. We can click on different emoji to vote on them, and then we can pick another one, and we can take a look at the leaderboard where we can see what all the different votes have been. It comes with a bot that votes randomly, so you can see there's a lot of votes that have already accumulated here from that bot. It's just a very simple demo application. If we go back over to the Linkerd dashboard, we can see that there's the Emoji Photo namespace here now in the dashboard, but you'll notice that there's 0 of 4 meshed pods here. And what that means is that the Emoji Photo namespace has 4 pods, but none of them have sidecar proxies, which means we're not able to collect any metrics for those pods. We're not able to do MTLS or do any interesting things that the service mesh lets you do. So the next step is going to be to add those proxies to those pods. So in order to add sidecar proxies to each of those emoji voto pods, all we have to do is get those manifests again. So run.linkerd.io/emojivoto. And we're going to pipe that through a Linkerd command called Linkerd inject. And the Linkerd inject command just does exactly what we want. It's going to add those sidecar proxy containers to all of the pods in the emoji voto manifest. And then we can take the results of that and put it right back into kube control. And so we can see here that it's told us that these 4 deployments have been injected. If we look back at the dashboard now, we can see that there are 4 of 4 mesh pods now. And so we should see metrics come in, and there they are. We see success rate, we see requests per second, latency data for the emoji voto namespace. And we can even drill in further here, and we get a little map showing which deployments are calling which other deployments. Here we have vote, the vote bot calling web, and web calls these 2 others. And we can see stats broken down per deployment, so request rate, success rate, and latency. We can see individual pods, and so on and so forth. And if we even drill further down and look at an individual deployment like web, we can see exactly which other deployments it talks to and the success rate on each of those edges. So we see that when web sends requests to emoji, the success rate is 100%, but on the other hand, when web talks to voting, the success rate is quite a bit lower. So that indicates that there's some problem there. So this is a great debugging tool for understanding where your traffic's going, where it's successful, where it's not, and where latency happens. We also have a table of live requests, so we can see exactly which requests the web deployment is getting and sending, as well as whether those requests are successful and how long they take. So we can see right away that there's a 0% success rate on this one path here, vote donut. And so that immediately lets us kind of zero in on where the problems in the application might be. All this data from the dashboard is also available on the CLI. For example, you can run the command linkerd-n emoji voto stat deploy, and this will give you stats for all of the deployments in the emoji voto namespace. So here we see that same information we saw from the dashboard in the CLI. So I hope that was helpful. I highly encourage you to give it a try yourself. As you just saw, it's very easy to try and get started with. If you have any questions, please head on over to our Slack channel, slack.linkerd.io, or find us on GitHub or Twitter. We'd love to have you participate in the project. Thank you very much.